Welcome everybody to an explanation of how to do a transfer question in Solver. We are doing linear programming, and the particular transfer question we've chosen to do is transporting green peppers to 4 different customers from 2 different warehouses. In a previous video, I explained how to set up your problem. So define the objective, the decision, and their decision variables, and the objective function, which is to minimize the cost, and the constraints to adhere to how much we have available from each warehouse and to adhere to how much each customer has ordered. You can watch that video for details on how we did that. Just a recap on what we're working with. Because we're trying to minimize costs, what we were given in the question is the cost of delivery to each customer from each warehouse. And depending on what warehouse you come from and where you stay, that's going to vary. So you've got a table that details those variations. What we're trying to do now is figure out how many green peppers to send from each warehouse to each customer in order to have the least cost on our trucks, on our transport system. I'm going to copy this table into my solver setup section of my question. And I'm going to copy my objective function so that I can refer to these 2 things as I explain this section. So remember that what Solver wants to ultimately do is give you a minimized cost solution. That minimized cost solution is based on this function. It's each cost times the number of peppers that are going out to the customer from warehouse 1. The $3 that it costs to come out of warehouse 1 to go to AMA times however many peppers will go to AMA. Okay, so that's warehouse 1, customer 2. That's this section of my table. And we do this for every customer for each warehouse. Now, what you're used to seeing is a list of all of your decision variables and then their costs beneath that. And we've done that with our manufacturing questions, with our construction questions. When we only have a few decision variables, that works nicely, okay? But when we have a lot of them, if they can be set up in a table, it makes your life easier. So I'll show you how we can do a similar thing, but in a table setup. So the only difference is, instead of having all of our 8 variables across the page and the 8 costs, these 8 costs, beneath them, we've got the costs together in 2 rows. So what I want to do is do the same for the decision variables. And then I've got my two rows that I need to calculate my objective function. Except instead of rows, they're tables. Now, if you think about what makes up your objective function, you need your decision variables in here so that you multiply your decision variable cost to the function. So suppose I'm just going to put some made up numbers in this section. Solver will actually give us the answers to these numbers later, but for the purposes of explaining how we come up with the setup, I'm going to put numbers in there. These are dummy numbers. At the end of the question, I will take them out so that you can see how Solver then gives us the solution. So I'm going to highlight this in pink so that you're always aware of what is coming back from Solver is highlighted. Okay, so any highlighted cells in this section are what Solver is giving us back. Now, I'm going to put in dummy numbers here. So suppose that in order to make sure Mary got 35,000, we took 15,000 from warehouse 1 and 20,000 from warehouse 2. I'm just going to reformat these cells to be currencies because these are the numbers of green peppers. Okay, and I'll do the same. Say Alma gets 12,000 from warehouse 1, which means she's getting 10,000 from warehouse 2. Mrs. Bucket, let's give her 15,000 from warehouse 1 and 3,000 from warehouse 2. Let's give Jude 15,000 from both. Okay, these are just made up numbers. What I'm trying to do is demonstrate to you how we can set up our constraints. Our first constraint is that we must adhere to how much is available at warehouse 1. So we cannot exceed 60,000 from warehouse 1. You'll see that our available products are already here. So I'm going to put these alongside here. What I want to do is set up my constraints so that I have a right-hand side and I've got a left-hand side that's worked out based on the numbers that we've got and the sign in between, so that when I put this into Solver, it's easy. I don't have to select too many things. So right-hand side, which is what is available. Left-hand side is what will be used or delivered. And in the middle, I'll have my sign. Okay, so all I've done is say, if this is how much I have in total, I know that all of these added together must come up to less than or equal to what I have available. So I'm going to add these up. Everything coming out of warehouse 1 cannot exceed what's available in warehouse 1. The same is true for warehouse 2. It's coincidental that those numbers actually came up to not exceed that, because remember, I'm just guessing these numbers as we go. Solver will give us exact numbers. Okay, and I'm just going to make these a different color so that you know that this is what goes into Solver. We will give Solver those numbers. We will give it the right-hand side. It will give us back the left-hand side, or at least the left-hand side will be calculated automatically when Solver gives us these decision variables. So I'm going to also highlight this just so you know that this will come out of the solution as well. I can do the same for my constraints on the orders that the customers are making. So far I've covered my first two constraints. Now I'm going to go into how much each customer must get. If you think about what we just did above, what was available was the right-hand side. I'm going to do the same thing with the orders. The right-hand side is what the customer has ordered. This is the right-hand side. This is the left-hand side. So I'm going to shift this down. I'm going to call this right-hand side. What was ordered. Left-hand side. What was delivered. And in between is a sign. And remember in the previous video, we said that if you make an order for something, you expect exactly that. You don't expect less. You'd be happy if you got more, but if you're the supplier, you don't want to sell more. I'm just going to format this better. Okay. Now, for my left-hand side, if if Mary has ordered 35,000, then what gets delivered must equal 35,000. And remember, her deliveries can come from both warehouses. You can also refer to the constraints in the setup. So warehouse 1 C1 plus warehouse 2 C1 must equal 35,000. So here the sum of what's coming out of warehouse 1 and 2 must equal 35,000. And the same is true for all 4 customers. Okay, this has worked out because that's how I guess my numbers. I'm just also going to add formatting. Okay, so these are the constraints that we would give solver, and we would give solver what the maximum can be. And when solver calculates the decision variables within our table, then our left-hand side will also auto-calculate. So I'm going to highlight that. Everything highlighted in here will come out of your solution from solver. Our optimal solution, which is our minimized cost. Okay, this is the fun part. Instead of multiplying my objective function by saying 15,000 times $1, as per this function, plus 12,000 times $3, plus 15,000 times 50 cents, plus until I do all 8, I can use a sum product formula. The sum product formula is a gift from God, from coders. Okay, I'm going to take a sum product of the entire array of my decision variables and multiply that by the cost. Okay, and that would be my minimized cost. This would be money, and I'm going to highlight this as well. I'm going to put it in green, bright green. This would be how much this transport company would spend on the distribution that Solver comes up with. Now, how you do your colors, etc., is up to you. When you constraints, you're going to give solver everything on this side. You're going to give solver everything on this side. You're also not going to forget your non-negativity constraint and your integers. And then it will work these out for you. Okay, I hope that's clear. The last thing would just be to say, don't forget to take these out because these were dummy examples. Okay, so Don't forget to remove all your guesses. At the end of the day, Solver is going to give you the section. The light pick section is next video, we'll put this into Solver.